Yeah, I'm here to talk about virtual local area network, which is VLAN. VLAN can be defined as, logical grouping of users departmentally, or a way of breaking large brokers domain into brokers domains. That is into subnetworks, creating subnetworks from one large network. For instance, look at this. This is a switch connected, connects these devices. These devices could be, more than 200 devices. It could be 300 devices. Putting them into, remember that in a company where they have several departments, logistic department, just like I have created here, marketing department, human resources, legal department. So leaving them in a large network is not a good practice. As a network administrator, it breaches the security. It can cause so many things. It can bring the network down. When one user sends a broadcast and every user decides to reply that broadcast at the same time, there will be a problem. That network may shut down because of, bandwidth degradation. So let me not talk too much. It's a process of breaking, this is one large broker's domain into broker's domains. Because switches breaks, broker's domains. Now, let's get into this configuration. There's no need to talk too much. Let's open this switch, because this is where this configuration is going to be made. Yeah, this is our switches. This is our switch, sorry. So let's get to command line and create configure terminal VLAN 1, VLAN 10, because I'm going to create 3 VLANs. Name, let me check the name of this VLAN. Yeah, VLAN 10. The name is VLAN 10. Then logistics, sorry. Separate it. Exit. VLAN 20. Name HR, which is human resources. HR. Exit. VLAN 30. Name marketing. So let's do show. From global configuration mode, you say do show VLANs. These are our VLANs we created. We have created, broadcast domains here. Now we need to map this broadcast domain to their respective interfaces. What do I mean? Let me show you. you can see this is an interface switch port FO/1, interface switch port FO/2. Now VLAN 20 is interface. The computers connected there is in a interface, switch port FO/3 and FO/4. So let's go ahead and map it. Interface range. If you want to map more than one, FO/1, sorry, 1 to FO/2. Switch port mode access, switch port access, VLAN 10. We go back, exit, interface range, FO/3 to FO/4. Switch port mode access, switch port access, VLAN 20. Now we go back, interface range, FO/5 to 6. Switch port mode access, switch port access, VLAN 30. Now let's get to privilege mode and do show VLANs. Look at those interfaces here. You can see logistic VLAN is at the interface FO/1 and FO/2. Look at it. Then HR, resides on interface. You can see it FO/3, FO/4. Same thing to VLAN 30, FO/5, FO/6. So now VLAN 10 can contain up to 254 because of the address. Yeah. So the same thing to VLAN 20. So they are on their own broadcast domains and they can communicate PCO according to its own domain. Okay. 192.168.10.2. Remember, router have taken the first address. Router will take the first address, which is this. Okay. Let me go to PC. I'll do that to, that's PC1 here. PC1. Okay. We take address number 3 on that domain, 192.168.10.3. Come down 255.255.255.0, which is the subnet mask. The default gateway is this. So let's configure other VLANs with their own associated IP addresses. Yeah, this is the last. What's the problem? Why is this thing slowing? One 192.168.30.3. Okay, 255.255.255.0. Okay, so now we are ready Do you know that this PC on VLAN 10 can only communicate with its neighbor PC on the same VLAN? So let's try, let's see it. There's no need of talking too much. Let's go there. This is on VLAN 10 with IP address of 192.168.10.2, and the other computer connected to the same is, you can see they can communicate. So let me ping the other computers on different VLANs, 192.168.20. Ping 192.168.20.2. You can see it cannot go because they are on different VLAN, so they cannot communicate. Each VLAN can only communicate with neighbor PCs or the PCs on the same VLAN. You can see logical group of users. Now, because this is a company's network structure called router on a stick, for these VLANs to communicate, we need to configure what is called inter-VLAN routing. Inter-VLAN in this router, and create a trunk link, here. So let's create the trunk link before we go ahead. So let's open on our switch. Let's open the same switch. Config T interface go/1 switch port mode trunk. Yeah, we have created a trunk link. Save your configuration. Now go to router, where we are going to create going to create different brokers domains and assign gateway addresses to each of these VLANs. So this is the router O. Let's maximize it. Okay, we hit the command line, interface, enable to get to privilege mode, configure terminal, interface go/O. Remember that LAN interface, switch port, no shutdown. Enable it with no shutdown. Look at it now. It has changed state to off. That is your first, configuration in this router. Just enable this interface here that runs at gigabit speed from the switch. Now, let's go ahead and enable sub interfaces. Go back, interface gigabit O/O.10. You can see it, encapsulation .1q. .1q, you place 10 and hit here, enter. IP address 192.168.10.1. That's the first usable IP address on that address space. .o. So this .1q here is the trunking protocol is a standard, an industry trunking protocol developed by the Institute of Electrical Engineers, often referred at 802.1q. 802, the number they gave it is 802.1q, is the networking standard, networking standard that support VLAN tagging, for virtual LAN, virtual local area network, on Ethernet network. Ethernet 2 is a standard, that was developed by Institute of Electrical Engineers. The number of the Ethernet is 802.3 Ethernet standard. Why this VLAN tagging, is 802.1, is a trunking protocol for VLAN tagging. You can see here, I have tagged this VLAN 10.1Q10. So it is going to be used to recognize VLAN 10 on that trunk, because several VLANs, other VLANs are going to be passing through that trunk, using their tagging, their number of VLANs. Now interface go/o.20, you can see it here. Enable, you can see VLAN 20 change state to up. You can see encapsulation, which is this trunking protocol .1Q, 20 IP address 192.168.20.1.255.255.255.0. Go back. Is it interface go/o.30? Remember, VLAN 30 is up. You can see when you hit it, what we are doing here, we are creating sub interfaces. Sub inside interface. So now encapsulation is the trunking protocol, which is .1Q. Then a target with VLAN 30. IP address 192.168.30.1 255.255.255.0. Now save your configuration. We are done with this configuration. Now let's try that ping again from PC 0. Remember, I pinged this LAN. Look at this IP address 192.168.20.2, and it was not successful. Look at the pinging statistics. Packet sent 4, received 0, lost is 4, 100% loss. Now let's try it again and see what is going to happen. Okay. Remember, it's going to show you one timeout, and that one timeout is what is called, look at it, it's there already. That one timeout, let me tell you what really happened. So look at it. Every ping, let me ping VLAN 30. A computer with address of 2 in VLAN 30. Let me ping it. It's going to do one timeout again. Do you know why? It's address resolution protocol. It's asking because it's going to another subnetwork. I'm pinging from here. It broadcasts. When I ping a computer that is another LAN or another subnetwork, this computer here send a broadcast. If you are the owner of this IP address, please reply me with your MAC address, because if it comes to Ethernet network, here they communicate using what is called media access control address, which is physical address. Do you understand? LAN, computers on a LAN communicate using their MAC addresses. Is only when they are going to different network they use their IP addresses. So it broadcasted, and because it's not in the same network, router here responded with its own, because router stores all the network addresses in its routing table. router responded with its own MAC address, because from here a MAC address in it responded and say, here is my MAC address. The network you are looking for is not in your domain. So bring it, let me route the packet into the network you are looking, the destination network. And that was what happened. So switch now store that MAC address in its, context addressable memory. Look at it here. Show, this is switch, show MAC address. Is this show MAC address or show MAC address table? Show MAC address table. Sorry. Look at those MAC addresses. Because of this communication that took place, switch had to, don't worry, when when I get to routing process or MAC address learning, you will know how these MAC addresses are learned into switch, MAC address table. So if you find this interesting, go ahead and share this video. Thank you. Make sure you watch this video regularly so that you know, if you are really interested in studying Cisco networking. Thank you. See you in the next video.